Just this one, brilliant. Thanks for that introduction. Yeah, there's a project on there I wasn't supposed to talk about, but never mind. So yeah, what I'm going to talk about today is real-world IFC workflows for COBie. So how we take these sometimes huge models and actually use IFC in the real world, but actually at the end of the day produce a COBie deliverable on a project. So I'm Adam Ward, I'm one of the founding directors of BIM Technologies, which is a BIM consultancy, and I'll come on to that in a second, and BIM Store, which is a BIM content distribution platform. I also head up the specialist R&D team at Space Group, so we have a whole team of developers, coders, who just make square pegs fit in round holes. So as that previous presentation, there's lots of databases we're using, and how we link those databases together, how we present that information. We have a whole team just doing that. And I am a geek, so I've been using Revit since version 4.1. So I still work on the projects. I don't kind of float above them, for want of a better word. In our group, we've got various companies. This is some of them. It's a 60-year-old business, an architecture business, fully digital. Everything we do is in 3D. I wouldn't call it BIM, but everything we do is in 3D. We've got a BIM Technologies business, which is our BIM consultancy, which I'll go into in a second. We've got BIM Store, which is a BIM content business, and we've got our development business as well. But I'm really here to talk about BIM Technologies. So what we do with BIM Technologies, we work for clients. So a lot of clients, we actually write the EIRs and we do the protocols, the standards, set up the, implement BIM into their business. But on the other side, we also do the very technical. We work with contractors, we work with subcontractors, and we actually deliver the projects on behalf of those clients as well. So some of the projects we're working on, or have worked on, is North Wharf Road in London, the Parabola Design Museum. We BIM consultants for John Lewis, so we did Victoria Gate Arcade, but every single new John Lewis store, we wrote the BIM standards and protocols on that, and EIR documentation. Chelsea Barracks, huge project, the one Prince Charles got involved with. Phase 4 we involved with. New ITV headquarters. So we mainly work on big London stuff, if I'm honest. Almost all the buildings are King's Cross, so about 22 buildings. What Arjun wanted to do was write a standard data deliverable, because there was different contractors delivering each building, and when you got to the end of the project, you didn't want different asset information models in different formats with different data. So we wrote a site-wide strategy about how each one of those projects was going to be delivered. Rathbone Place, Facebook's new offices and some really high-spec apartments. This was kind of taking it to the next level. So every single thing, there were 680 subcontractor models in here, mostly IFC, because when you get to the subcontractor trade packages, they tend to be very specialist design software. So IFC is the logical step to bring that in. So you can see on there, we've got the staircase with all the fixings, we've got the reinforcement bar in the slabs, we've got the facade with all the noggins on, 680 models. And obviously all those models come together, and we try to get zero issues. So you can see the block works, actually, every pipe work's got the builder's work in, etc., etc. So we try to get the model as construction ready as possible. The big one is Brent Cross Shopping Centre. Now when it comes to the traditional workflows, this is difficult because it's like working on 12 buildings on one project and then you redirecting the motorway, redirecting the river. So the civils are massive on it. So how you split the model up, how you break it down is all important on a project like this. So you can see it's inside. All the civil 3D models coming through, again, using IFC for most of it. Right down to every single detail on there. And this is just coming up to the technical design stage. Then the last type of project we get involved with is when we get a phone call after the building's been handed over and you say, we need to deliver a COBie. And then we get called in to kind of reverse engineer and deliver that asset information deliverable when the contractor hasn't. This wasn't that project, by the way, but we get that quite often. So we get called in quite often to solve problems. Not the ideal way of doing it, that's what we do. The last bit of our projects, and then I'll move on to actually how we do it, is we work on little stuff and all. So our architecture business is the main architect for all of the new little developments. We manage the central stores. Now, that's not like your typical large building where it's a big, unique, complex building. Every store is pretty much identical. But because it's a German organisation, it's very dramatic about how they deliver it. So very off-site manufactured, very specific, highly engineered. And again, we do everything for Barrett's. So all the new house type ranges for Barrett's, Barrett's are fully digital now. Now you're not really interested in the coordination, the federation, because you built these houses 20,000 times. What they're more interested in is how you can use that single asset for market and visualizations to when a regulation changes, such as Part L compliance, how you can go and change 300 house types overnight. So that's why they're using it. And what Barrett's have done is, using IFC, they've asked all their supply chain to deliver Revit models, which was a bit controversial. So he said to everybody who supplies their objects, we want Revit models. But for some elements, such as joists, trusses, systems, for want of a better word, we get an IFC files which are then linked in. So what Barrett's have is a digital representation of the building, which is linked into the procurement system, which is coins in this case, and can be fully managed on their digital platform. So out of all the live projects we currently have on, this is a good overview of kind of how many is asking for data. So we have 38 live projects. 32 of them have a data deliverable. Out of those data deliverable, 15 of them is a COBie requirement. So a lot of clients want data, but they want data which is their unique data system, which in my view isn't ideal, but a lot of clients still actually saying COBie isn't useful to me, doesn't do what I want it to do. So we try to educate them about actually how it is a benefit to them, but we don't succeed all the time. Out of those 15 with COBie requirements, there's only 2 of them, and they're both government projects where we have to do staged deliverables. So typically, even the ones which are asking for COBie, he's saying we just wanted COBie information deliverable at the end. We're not really bothered about dropping it at every stage to check it against the PLQs, etc. So the process we use at BIM Technologies, and it varies depending on project to project, because every project's different. So we review what software is being used, how the models are split up, and then we tweak it to suit. Now there's various ways to produce COBie. So this is Rathbone. There's 680 models in there, all from the subcontractor. The first thing is, we plan this out and we document it. So every subcontractor, we do digital deliverables. And what they do is they break it down in plain language exactly what data they need to put in the models at what stage to the actual exactly what they need to do. And I'll show you that in a second. Now there's lots of ways we can extract the COBie information from that federated IFC model. The way we don't do it is the Autodesk COBie toolkit, and I hope there's nobody from Autodesk in the room. But the problem with this is great if you're an architect and you've got to deliver a COBie for the architecture up to stage 3. What it's not so good at is if you're working on a big project and you've got 500 subcontractor models and you've got some Tekla models and there's 20 buildings on the site and you want a single COBie file, this tool will kill you. So the only real way of doing it is the IFC workflow. So this is typically your normal, you have beginning of the project, you have structure, architecture, MEP, come together, federated every 2 weeks. It repeats that process and issues found, etc. Link in the logistics, link in the program. Then what starts to happen is we start to link in subcontractor packages. Now, so for example, if there's a COBie deliverable at the end of the project, what the client needs, and the client says, we're not bothered about stage deliverables, we just want a COBie at the end, then why would we waste our time getting the MEP engineer at the beginning to put the COBie data in, when actually that model is going to get turned off and replaced by the subcontractor model? So what we make sure we plan out exactly who's responsible for what data at what stage. And this is how we used to do it. We used to have a two-prong approach. We used to get the brief. We used to, every 2 weeks, get the architecture, the structure, the subcontract to spit out IFC 2x3 coordination view 2 files, and at the same time export NWC files. And it was a two-stage process. We used to use the NWC files to coordinate for clash detection and issue management. And we used to use the IFC files for model validation and ultimately COBie creation. And the reason for that was back in the day, and I'm only talking about 2 years ago, there was a big, the information produced by IFC, people didn't really trust on the projects we were working on. And it was a misunderstanding. It was because it was more to do with the software, and they hadn't set up the mappings properly. And the different softwares interpreted slightly different. And that caused huge issues in the industries and made a lot of people lose trust in IFC. But what's quite cool is we're at a stage now where actually I think that trust's coming back. And we've actually, on most projects now, we're getting rid of the Navisworks top files and we're using IFC. So we're still using Navisworks to federate them, but we're sticking with that single IFC data set. And what this allows us to do, all the data in the proprietary software, the architect might be using Revit, structural engineer might be using Tekla, your subcontractor might be using CAD duct. And the data structure is different in each one of those bits of software. So what IFC allows us to do is standardize that data, federate it once it's standardized, and then obviously extract the data, the COBie schema out of it. Makes it look simple, but it's a bit trickier than that. But basically what we're doing is we're taking unstructured data or proprietary structured data in different formats and different systems, and we're just structuring it. So that's kind of the way I think of COBie. It's a way to take data and organize it in a very nice fashion. One of the most important things is we need to make sure, because we're in quite a fortunate position because we normally write the standards and we involve sometimes before the architect, before the subcontractors, etc. So we can make sure that the project's set up right. So we write the EIRs if we at that stage. If not, we get involved heavily in the BIM execution plan and all. And we actually break down in a lot of detail exactly who's responsible for what stage, what level of definition they model into, what assets they're responsible for, right down to actually what properties in that asset they've got to produce. Because one of the problems with IFC at the moment is, unless you're, probably you guys in this room all understand it, but if you're an architect and you're quite new to it, trying to understand the very technical like TC1 schema and understand the structure of IFC can be quite daunting. So we break that down to be, if you're using Revit, these are the shared parameters you need to put in your file, and that's how you do it. If you're using Bentley, this is how you do it. If you're using Tekla, this is how you do it. We do use the Autodesk plugin, but the only reason we use it is if the architect, if there's no data in the model, we can very quickly push those default COBie information into the model. That's kind of when it's okay to use it. Yeah, so each discipline's model is brought to IFC, it's then federated, we can then extract data out. We used to have problems where if different people use different versions of the exporter, it exported slightly differently. So it's important to make sure that everyone's working to the same flat line. So step 3 is we then, once we have those individual IFC files, we bring them all together and we use Celebri. So this is our IFC workflow. We bring those models together in Celebri and we QA check them. So before we extract the data out, what we do is we check that the data is correct. So not that the data is correct, but that the models are modeled properly. So there's no overlapping elements, every element's in a space, etc. And we have Celebri rule sets which we've modified to do that. We use a lot of out-the-box ones, but we've added our own as well. Then what we also do is we run classification. Ideally, when we get those IFC files, and you'll have been offered in a way where all the data's in, it's in the right place and it's perfect, but sometimes, 99% of the time, that's not the case. So what we've done is modify our Calibri rule sets to kind of pick up those known issues. So we've got various mappings in there to automatically get over those issues. What we tend to do first is chuck those models back to the author and say, this data is missing. But bear in mind, sometimes you get this after the project's finished. Trying to get them to do that's impossible. So we have got some very rules that can do that. Yeah, so we use the Calibri to COBie toolkit to extract the data, but we've modified it slightly, like I say, and it populates the Excel file. Now, I'm not going to do a live demo. So even when we do that, though, it's not perfect. So we get all these models, we bring them together, we extract the COBie, there's data missing, there's stuff wrong. So what we do is, we round trip it. So there's no need to do this. This isn't kind of a level 2 BIM requirement, but we think the model is the perfect place to store that data and manage it. Skip this. So what we do is we extract, let's go back, the architect exports IFC from the model, or models. We bring them together in there. So it says Google Docs. We used to use Google Docs, but we've developed our own better system to do it now. So what this is, we extract the COBie out, we find in the blanks, we then issue in that original, think of it as a Google Docs file, back to each design team saying fill in the blanks. Then what we do is we pump that back into the software. Depending what the authoring software is, we use different tools. We have about 10 different tools. Sometimes we use BIMlink if it's Revit. We use Affinity if it's Bentley. We have our own system called Stargate, which kind of works with IFC natively. And the reason for that is when you hand over a COBie file, we don't want to be typing manually in here. We want to be pushing it back in. So what we do is we give a file, we say fill in the blanks, we chuck it back in the model, we then rerun the Calibri extract, see if it's been populated, and we have to do it about 4 or 5 times until all the data is complete. Yeah, we use the BIM container for the model for the data. Like I said, it's not a requirement. You could just type it into COBie and hand it over, but then your model is technically could be out of sync of your data. To be honest, the biggest problem is not the tech. I mean, I think we've pretty much cracked it now. The issue is more the people. So we can tell people 1,000,000 times at the beginning of the project what data you need to put in the model, where you need to put it for it to export properly to generate a COBie through IFC. The problem is trying to get them to do that is sometimes hard. And I think one of the reasons is IFC has got a bit of a reputation of being a bit complex, a bit techy. I mean, I understand this, but most architects will kind of fall off the seat when you start getting into this kind of information. And a lot of documents just refer them to here. And in the future, we're looking at tools like Glider BIM, and I'm not being paid to say, I'm not advertising it here, but this is a tool where at the beginning of the project, you can create the requirements, the employees' information requirements. Every 2 weeks, you upload the IFC files and it tells you what's missing against those requirements. You then click a button and generate a form, which is then pulled back through and generates the COBie. Again, making it look simpler than it is, but it's taken all that manual process I've just shown you and putting it on the cloud and making it a nice interface. So one of the last things is, I think, is IFC 4. It's going to make a huge difference because one of the problems with IFC 2x3 was when the architects saw this on the right, architects are very visual, and even though actually that's perfectly fine for most coordination, for most bits and pieces you're doing with IFC, that kind of just looks blocky on the drawings, and you don't like it. Now with IFC 4, with the new geometry definitions and NURBS support, etc., I think that's going to be a massive improvement to get over that. Plus, going from the number of properties in the schema from 15 to 30, that's going to be quite a big difference and all. And with the new model view definitions like the reference view, which makes it gets rid of a lot of the issues where geometry used to go missing or flip the axis. It seems to just be a lot more robust. And I've been testing the new Revit 2019 IFC 4 certification, and it's a massive improvement over the 2x3. So IFC 4 on the right, IFC 2x3, IFC 4 on the left, IFC 2x3 on the right. And every project is different, so this is one of my last slides. What I would say is, even though I've explained how we do it on most of our projects, people like Lidl, people like Barrett's, inside each one of those models, every single element is actually a manufacturer object. So you could go and generate a COBie from one of those models using the Autodesk toolkit. There's no structure, there's no 200 trade models, it literally is one model. And everything is in there. So every project's different, and we look at each project individually and decide the best way of doing it. So that's my last slide. Thanks for your time. Is there any questions? What I got away with it.
Thank you very much. That's very informative. Can you just please clarify again, if you already have a COBie drop, for example, from the architect side, and you want to populate more information into it at this next drop, yeah. How do you do that again? Do you automate it? Or?
It's difficult. So if we get given a COBie file from an architect, then we need to do one for the next drop. Unless we have access to the models where that was generated from, it's very difficult to type stuff in manually. The reason being is everything is interlinked. So on the type sheet, it's got what component it is, and on there it's got what component, which room it's in. Then in what room it's in, what documentation's linked to that room, and everything's interlinked. So it's very difficult just to type it in. So unless you have that original process and original, it doesn't have to be a 3D model, but that original database to extract it from, it's very difficult to do that.
So what do you do in this case? How do you add the extra information?
Well, in the COBie, I've never done that before, if I'm honest. What I would do is try to get hold of the models where it came from and try to basically recreate the drop.
The whole thing from start?
Yeah, because
everything?
If whoever's created that file has created it from a model, a database, that database should still be structured, so the data will be in there, so to extract it out should be straightforward. The problem is if we just get an Excel file and we don't have access to how that was created, the only option you're left with is to type it in, and that wouldn't even want to go there, to be honest. Yeah.
Last question from Frank. So as well. Okay, we'll fit 2 more in.
So thanks for your presentation. So if I got you correct, you said that clients have some, let's say, objections about COBie. So what's
used to, I would say.
Yeah, but how is it today?
It's getting better. I think the problem was he didn't understand it. So he just wanted what he'd always gotten. So if you were a client in your FM team have always did stuff the same way and wanted the same data, then all of a sudden you're giving them something else which is different. It might not contain all the same information they used to have. You kind of, just give us what I've always had. The way I describe the clients is what kind of explains COBie really well. It's a bit like having a classic car. So if you have a classic car and you have the full service history of all the items that were maintained on, because COBie's in operation and all. So when that building's in operation and something's replaced, what it was replaced with, who replaced it, all that's logged in that system and can be exported back out to COBie. So by having your data in a standard schema, it allows you, if you sell that building to somebody else, you can just transfer it over. Even if you're using a different FM system, because it's using that standard BS schema, it just transfers straight over. So instead of every client asking for different data at the end of the project, there's now a standard schema which you can ask for. And the real cool thing is a lot of software now starting to support it. So stuff like Navisworks, Revit are now starting to do COBie exporters. Stuff like FM platforms, like Planet FM, Maximo are now starting to do COBie importers, or even IFC importers, some of them. So you've got this whole workflow of data exchange. And I think the problem with one of the other things I forgot to say about IFC is I think in future we need to stop thinking about it as a file, which it isn't really, and think about it as more of a data schema. Because in future we won't have files. Same as you used to download music as an MP3. Now it's all streamed, it's on the cloud. And in the future, I think that's where models will be. And they'll just be hosted on the cloud, and it'll just be a schema to get the data between these different silos, for want of a better word.
Sorry, Frank. Last question for Russ, because we do have to move on.
Thank you for your presentation. I'm responsible here in buildingSMART for the certification of the software systems.
Yeah.
And I'm really happy that you already looked into IFC4 in the reference view.
Yeah, I was in Shanghai last week looking at the testing, and it was quite good.
And yes, for the design transfer, we actually have the challenge that we have to identify really the requirements, the purposes.
Yeah.
So the question to you, since you obviously have a lot of experience how you use IFC in practice, would you be willing to help us here?
Yeah.
Very good, thank you
Yeah,
very much.
definitely
we'll
give it a
catch
go,
up after the break. Thank you.
Brilliant.
Thanks again, Adam.
No problem.
Fantastic.